Last but not least, we have some application problems. So number 4, which of the expressions shown represent the volume for the cylinder where r is the radius and h is the height? So first thing I'm looking at the cylinder. It wants me to figure out volume of the cylinder. The first thing I'm going to look at is, well, what is the volume of a cylinder? And if you're not sure, that's what Google's for. Go Google volume of a cylinder. But the volume of a cylinder is pi r squared h. Now, I'm looking at pi r squared h. That's how you find the volume of a cylinder. And I'm looking over here, and none of these look to me like they're pi r squared h. R represents the radius, h represents the height. I'm looking at my cylinder over here, h is the height, but it looks like instead of radius for r, they have h over 2. So I'm going to take that and I'm going to say, okay, well then I'm going to take my radius and I'm going to substitute h over 2. So volume equals pi times the radius, which they have as h over 2, squared times h. Now I'm going to go look at that again. Nope. I don't think we've got anything right now that I would just identify, so I'm going to go from here and see what happens. If I use my properties of exponents, I have h over 2 squared, which means I can rewrite this as h squared over 2 squared because I distribute my power. Then we're still going to have h, we're still going to have pi, and that is still equal to the volume. From there, I'm going to look at this h, and I'm going to put it over 1, because then I have a fraction times a fraction. So if I do that, I'm going to have volume equals pi times h squared times h is h cubed over 2 squared times 1 is 4. Now I'm going to start looking at that again, and I see something that I think would work. And what I see is I see this guy right here. The only difference is they also put the pi over 1, and then they multiplied pi times h cubed, which is pi h cubed over 4, and it looks to me like this guy then turns into this guy. So then my next one is, well, what else could work? Or can anything else work? So I'm going to look, I'm kind of looking at this guy, wondering if I can get there. And in order to get there, I think we might have to go back to this step right here. So if we go back to that step right there, it looks like we had pi times h squared over 2 squared times h. Now again, if I put everything over 1, on the numerator, if I grab the pi, the h squared, and the h, we're going to have pi h cubed, because I'm going to multiply h squared and h, over, and then 1 times 2 squared times 1 would be 2 squared. But if I look at what they've got right here, they've got a 2 to the negative 2. So if I take my 2 and I do the reciprocal and stick it in the numerator, that would mean that I have to use a negative exponent. So I could do pi times h cubed times 2 to the negative 2, because you bring it up to the numerator, which would be this guy right here. Now, at this point, I happen to know that there is another answer, and we need to find it. So now I'm thinking, okay, I don't think it's this one because we already have 4 in the denominator, and I'm not really sure. I mean, if we've got pi h cubed divided by 2, but we know pi h cubed, I really don't think it's this guy. Then I'm going to look at this guy and kind of the same thing. We're dealing with an h cubed. We're dealing with an h cubed. We know that that's right. H squared doesn't seem right to me, so I really don't think it's that, which means I also really don't think it's this, because if this is a 4 in the denominator and I bring it up to the top, it would be 4 to the negative 1, but what happened to my h cubed? So now I'm looking and going, how do I get to that? 2 pi r cubed. And I'm looking at all my work over here, and the only place I even had an r was in this original equation. So now I'm going, okay, well, how do I get back to having an r when I substituted my r and this doesn't even have an h? Okay, so let's go down here and let me think about this for a minute. So the radius on my cylinder is being represented by h over 2. Well, what if I were to solve h, or solve this equation for h to get h by itself? I would multiply both sides of my equation by 2. So that would cancel, and I would get 2r equals h. Okay. Then I'm going to go back to my original volume, because I know that the volume of a cylinder is pi r squared h, and I now know that h is really 2r. So I'm going to substitute 2r. Volume equals pi r squared times 2r. And then I'm going to simplify. So volume equals, I've got r squared times r, and I've got 2 times pi. So 2 pi r squared times r cubed, and this is now that. So back to our question. Which of the expressions shown represent the volume for the cylinder where r is the radius and h is the height? We could use any 3 of these. So we could use the blue one, the red one, or the black one. They all work. Number 5. A jellyfish emits about 1.25 times 10 to the 8th particles of light, or photons, in 6.25 times 10 to the negative 4th second. How many photons does the jellyfish emit each second? Write your answer in scientific notation and in standard form. Okay, and then we'll get to this little reminder here in a minute. So first of all, we have to figure out what this is asking us. And the part that I tend to focus in on is it says, how many photons does the jellyfish emit each second? Okay, the other way to read this is emit per second. So he's emitting photons per second. So kind of like driving a car, miles per hour, meters per minute, gallons per whatever. When you see that, this is telling you if I want emit each second, photons per second, you want to divide. So these are your photons, these are your seconds. We're going to do photons per second. So we're first going to start up. We've got 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4th. That's going to give us our photons per second. Now, if I actually want to figure out for 1 second, that means you actually have to do this division problem. So in order to do this division problem, get your calculator, you can use your phone, you can use Desmos, just something simple. And we're first going to type in 1.25 divided by 6.25. That's it, just the part that I have in the green box, which is going to give us 0.2 times 10, and then we have to figure out this. So this goes back to one of our exponent properties, where if we have the same base, we have to subtract the exponents. So we're going to have 8 minus negative 4. Well, what is 8 minus negative 4? And that's 12. So now we're looking at, we've got 0.2 times 10 to the 12 photons per second. And now I'm going to go over here. There's a little remember, something about scientific notation. A number is written in scientific notation when it is of the form a times 10 to the b, where a has to be a number between 1 and 10. Okay, take a look at this. Is that a number between 1 and 10? And the answer is no. Okay, so the way we deal with that is we're going to take our decimal and we're going to move it over once. So we're going to put it back there, which is going to give us 2. But if we already moved our decimal over once to make it 2, that's going to change this. So it's going to be times 10. And the question is does this bump up to a 13 or does it bump down to an 11? So the way I think about it is 10 to the power of 12 would have told me to take this and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I already moved it over once to get the 2. So if I had to go 12 and I already did 1, how many are left to go? Well, now I only have 11 left to go. So 2 times 10 to the 11th photons per second is our final answer. And that is a lot of photons per second.